Hello everyone. Good evening to good evening to all of you. I'm so excited that we're going to launch or we're going to start our plan next year academic plan with this platform Nsmart. So welcome to our platform. So here we're going to start chemistry series. Every chapter we are going to discuss live. So first thing, since you are choosing NEET exam or your focus is on NEET exam, one observation, as per my experience, I observe one thing that mostly NEET aspirants, they are very much focused on biology subjects. Be honest, just whatever I'm saying, just agree or you can disagree also. So you are very much focused on biology subject. That's why you are choosing NEET. But one important thing is, whenever you see result, if you consider biology subjects, almost all the students are getting similar marks. But chemistry and physics, these two subjects are going to decide your rank, right? Now you can say that there is no connection between NEET, means I'm going to be a doctor, so there is no connection between doctor and this chemistry subject. You can consider, you can give that logic also. But the point is, it is not like that. If you want to become a successful doctor, you must understand chemistry. Because a good doctor always understands medicine very well. And to understand medicine, you must understand chemistry. Our body, it is just a chemical system. So if you have that confusion, if you don't have that basic knowledge or that differentiation, how you will differentiate one medicine from others based on their composition, based on their formula, how you are going to be a good doctor. So that's why your purpose must be clear. If you want to be successful, then you must understand chemistry. You must invest your time in this subject. That is the first thing. Second thing, you can say, sir, if I clear NEET exam, after that I can focus on chemistry, because whenever I'll become doctor, so it's a 4-5 years plan. At that time I'll study chemistry, then I'll recommend others, I'll whatever medicine, whatever you're saying, I'll be working on that. But the point is, just few minutes ago I said this 180 marks in chemistry, this 180 marks, it is the deciding factor. Because nowadays chemistry is very much scoring subject. So some of your friends, if they score more than 170 or 180, and if you are scoring 50, 60 marks, then your rank will be totally different, right? Biology marks will be almost same, and physics, we don't know, sometimes very hard paper, sometimes there is a complex thing. But chemistry, if you ask any NEET aspirant, those who already attempted, because I know since you are starting class 11th, you don't have that idea. Always talk to your seniors, those who already appeared this exam. Chemistry is very much scoring subject. So this exam also, that paper, almost all the questions were very easy. Although it has been cancelled, but if you see the paper, all are very easy questions. So if you invest your time and if you score well in this area, this 180 marks, then your rank will be improved. And that's why you must focus chemistry today itself. You have to study, you have to be, it is not like that rocket science, only you have to go with the, you have to study those each chapter, you have to maintain short notes, revise those short notes and practice. Just few things you have to follow. And this chemistry, it is just, it is connecting to different things. Physics and biology, it is in the intermediate situation. So it is connecting our body with the physics system or outside system. So that's why chemistry is very, very important for you. Accept that and start working. So here, first question is, what is chemistry? So you can imagine, you can define. How we will define what is chemistry? It is nothing but studying elements or studying matter. Now studying matter or studying elements means what? Means their properties, their composition, their how they will change with respect to their situation, with respect to their condition, how they will change. So this study is called chemistry. Basically till date we have total 118 elements, right? Total we have 118 elements. Last discovered element is oganation, OG 118, that is under 18th group, last element. So only we have to study these elements. And now since this whole subject, it is experimental subject, that's why so many things you find that some exception, lot of exception might be there. Those are not actually exception, those are it depends on that particular condition. We are saying exception, but it is not like that. Means those are not following trends, and whole chemistry is based on observation or pattern, and if something is not following that pattern, we consider that one as exception. But we have to focus on that one also. Something will follow proper pattern, something may not follow, but both the things we have to we have to practice, we have to remember a lot of things. So that is the thing. So here in today's class, since today we have the first class, we are going to discuss all the basic things. All the basic things means chemistry, how especially this matter, how we will classify matter, what will be their properties, right? All these basic things we are going to discuss today. So already we have said that chemistry means that studying matter, studying their properties, compositions, and how they will behave in front of other substance. These are like that. Now you can ask why we have this subject, what is the importance of this subject? See, this chemistry everywhere we are using, everywhere. If you consider that health, medicine, there we have. If you consider energy or environment, everywhere. Food, agriculture, then vaccine, everywhere. Just check all these main points we have. Material science, we have material science, nanoscience, or everything is based on chemistry only, right? Means that elements, those matters, right? So since everywhere we have this chemistry, and for you these are the main important thing: drugs, vaccines, medicines, this type of thing you will understand very easily if you have that basic knowledge or that enough knowledge in chemistry subject. So now we will classify matter. Now first, if I ask you what do you mean by matter, so we can consider, sir, matter means if something is having some mass, if something is having some mass, and if it occupies some volume, then that is matter. So matter means anything which is having some mass and which occupies some space or some volume, right? That is matter. Now in our regular life we have three types of matter. One is solid, then liquid, and last one is gas. So this is as per our regular life. In our real life we deal with this three types of matter: solid, liquid, gas. Although there are two more matters. One is plasma, that is fourth one, and fifth one is Bose-Einstein condensate. So we will discuss one by one. But this solid, liquid, gas, you must have clear idea what are the basic difference among them. In case of solid, just imagine particles. Whenever I say particles, it can be atom, it can be molecule, it can be ion, right? Particle means this is the common terminology in chemistry. So when we consider solid, their particles will be very, very close to each other. They will touch each other. If we consider liquid, they are not touching each other, but they are very close to each other. In case of gas, particles are very, very far from each other. This is the basic way, fundamental difference. In case of solid, all particles, they are touching each other. They are very, very compact, right? There is no space between two particles, or interparticle distance almost zero. Interparticle distance is minimum. If you consider gas, here interparticle distance, which is this, interparticle distance is maximum in case of gas. Now if you consider liquid, interparticle distance will be moderate. It is more than solid and it is less than gas. Now you maybe you have understood this one, but still I'll show one picture so everything will be clear to you. Just see this diagram. Here, this is solid structure, so all compact structure you can see. Liquid, flexible, particles can move here and there, but space, it is not like solid, also it is not like gas. So in case of gas, distance are, each particles, they are far from each other, right? Next, if you see their properties, any solid means fixed shape and volume. For example, if I consider this pen, it is having specific shape and also it is having some specific volume. If you consider liquid, let's consider water, definite volume it will have, but its shape is depending on the container, right? So variable shape. In case of gas, we cannot say anything specific to its volume or shape. It is variable. It is variable, right? Next, another thing, non-compressible. Solid, already particles are very, very close to each other. They are touching, almost they are touching. So you cannot compress or you cannot reduce that interparticle distance in case of solid. So that's why it is almost non-compressible or negligible. That compressibility will be negligible. In case of gas, particles, see the particles are very far from each other. So you can easily compress. If you apply pressure, then particles will be coming towards each other. That's mean compression, right? So particles will be coming to each other. So that's mean you can compress. Means if you consider 50 liter gas, from that you can convert that into 1 liter or 500 ml also by using pressure. So gas is highly compressible, solid is negligible compressible, and liquid is moderate. Okay, moderate. So these are the basic idea about solid, liquid and gas. And yes, another thing is there, energy. Whenever something is in solid, it is having lowest energy, and if something is in gaseous form, means that particles are moving here and there, right? So that's mean it is having very high energy. That's why remember, whenever we have, for example, water is liquid. Let's consider ice. Ice is solid. Now if you heat, if you just supply heat, then ice will be melted, right? So solid to liquid energy is increasing. Solid to liquid energy is increasing. Why it is increasing? Because we are supplying energy, right? This ice or water molecules are absorbing energy from surrounding. Again, if we supply heat, so this liquid will be converted to vapor. Vapor is in gaseous form, right? That vapor will be in the gaseous form. So that's why if you increase energy or molecules, if they absorb energy, if they increase their energy, so they will be going towards their vapor or gaseous form. And when they are losing energy, they will be going back to their solid form. So this is the normal trend. Okay, other than this solid, liquid, gas, we have two other state also, plasma and Bose-Einstein condensate. These two are totally different thing, extremely opposite to each other. Plasma means when temperature is very, very high, like our sun. So their temperature is very high. Now in that case, for example, if you consider this atom, if this atom gains lot of energy, so it is having lot of electrons, right? That electron will be released. When this atom is losing electron, you can consider atom or molecule, whatever you prefer. When this atom or molecule is losing energy or losing electron by absorbing energy, so now just check, electron is here and this atom becomes cation, right? So cation and electron, they are coexisting at this very high temperature. That specific state is called plasma state. Normally, if you put cation and if you put electron, they will merge together, because cation means positive charge will attract this electron and becomes neutral. That is the normal case. But when temperature is very, very high, extremely high, in that case this cation and this electron, they will coexist. Just check this. positive, negative, right? So they will coexist. This is called plasma state. And Bose-Einstein condensate means it is opposite, means extremely low temperature, close to absolute zero temperature. Close to absolute 0 degree centigrade means minus 273 degree centigrade. So close to absolute 0 Kelvin temperature. There what is happening? All atoms actually the advanced as per advanced scientific observation, that quantum model we have, particles behave like a quantum, they will, that wave and lot of things will be there. That Schrodinger equation you will study there, wave, everything is in wave form. So basically here what is happening, all atoms they will merge together, and all those atoms they will behave like a super atom, because all of their quantum state will be merging together. So that is Bose-Einstein condensate. Normally no one will ask question based on this. Why? Because these are not regular thing, right? This is extremely high temperature, and Bose-Einstein, that is extremely low temperature. These two are special case, but other three, these are important. Acha, next, this is another important thing, classification of matter based on composition. Based on composition, what does it mean? Now let's consider one thing, I'll explain in the next slide. If I consider hydrogen atom, then it is H. H, can it exist? No. Hydrogen atom, it cannot exist. It must be in H2 form. So this H2 is a molecule. So that's mean hydrogen element, its elemental form is hydrogen molecule. So this is element, correct? This is element and this is the molecular form. If you consider oxygen, only oxygen atom, can it exist? No. It exists in its molecular form. If I consider iron atom, can it exist? Yes, it can exist, Fe. So this is atomic form. These are all element. Just check hydrogen, both the atoms are hydrogen. Both the oxygens atoms are oxygen. Here this iron atom, it is also element, right? So if you consider gold, this is also element, right? Au. So these two are molecular form and these two are atomic form. So what do I mean? So all these elemental form, these are all pure substance, right? These are all pure substance, correct? Next, if I give another example, let's consider H2. H2 is element or compound? These are all element, right? These are all element and pure. If I consider H2O, just check two hydrogen atoms we have and one oxygen atom we have. So here we cannot say this one as element. We will consider compound. Compound word. So compound means at least two different type of element will be there. So here two different type element means H2O, one hydrogen, another one is oxygen. Another example, CO2, right? CO2, SO2, then H2SO4, sulfuric acid, it is also compound, right? So if we have at least two different type of atom, that will be called as compound. So these are all compound. And if you consider this is water, liquid water, this is pure. If you consider this is oxygen gas, CO2 gas, it is also pure. If you consider sulfur dioxide gas balloon, that is also pure. If you consider H2SO4 liquid, that is also pure. So that's mean these all compounds, they are also pure. When individual element or individual compound is present, then they will be called as pure substance. So these are all pure substance. Now if I give another example, another situation, let's consider we have water. We have water here, right? This is water. So this will be called as pure substance because only water is there. Water compound is there. Now if I add something into this, let's consider salt. If I add salt here and if we mix, then that salt will be mixed here, right? Now can we call this system as pure? No. This will be called as mixture. This will be called as mixture. Now what type of mixture? If you dissolve salt in water, they will form homogeneous solution. They will form homogeneous solution means you cannot isolate the salt and water visually. Normally by physical way you cannot isolate, right? But if you add sand, then sand particles, they don't dissolve in water. They will be settling down after some time. So that will form non-uniform solution. So sand will form non-uniform solution, and salt water, this will form uniform solution. Correct? So based on that, we have two classification in case of mixture. One is homogeneous, another one is heterogeneous. In case of sand water, we will call heterogeneous. Heterogeneous whenever something is not dissolving. Okay, sand water. Another example we have like blood, milk, chalk powder solution, clay, all these are heterogeneous system. If you consider salt water, sugar water, they mix with each other, right? So that's why that is uniform mixture we will get, means homogeneous solution you will get. So now up to here what we have discussed, element can exist in two form. One is molecular form, another one is atomic form. So element can exist in two different form, atomic form or molecular form. Both are called pure substance. If you consider compound means at least two different type of element must be there, like H2O, CO2, SO2, H2SO4, H3PO4, all these are compound. If only those compounds, specific those compound, individual compound is present, then pure substance. If you mix two different thing, then it will become mixture. Like in water you are adding sand or salt or something, that will become mixture. Now what type of mixture? Depending on the factor that whether it is dissolving or not. Salt water, it will dissolve properly, right? So that's why uniform solution you will get, and this will be called homogeneous mixture. Sand water, it will form non-uniform solution, and that's why it is called heterogeneous mixture. So this is the idea. Now if you see this diagram, then it will be much more clear to you. So matter, anything that has mass and occupies some space, or if something is it must have some volume. Now pure substance and mixture, two categories we have. Under pure substance, matter with constant composition and distinct property. Constant composition, what does it mean? CO2, its composition is fixed, right? CO2, you have your CO2, I have my own CO2. Both the cases, composition of CO2 is fixed, 1 carbon, 2 oxygen. And distinct property, so each compound or element, if you consider, they are having exactly specific property. Now here we have two things. Under pure substance we have element and compound. Element means, so here we have example copper, oxygen gas, gold. And compound, here we have H2O, salt, sugar, all these are compounds. And homogeneous and heterogeneous. Under homogeneous, so uniform composition throughout and single phase will be there. So salt water, air, our atmospheric gases, so they form homogeneous mixture. Then alloy, this is very important, alloy. All type of alloys, they are actually homogeneous mixture. Now heterogeneous means sand water, oil water, salad, all of this heterogeneous mixture. So this is the idea about classification of matter. Now next part, properties. So we have two different things. Every time you will hear two things, physical properties and chemical properties. Now physical properties means the substance will remain the same. Substance or matter will remain the same. In case of chemical properties, that substance or matter, it will be changed into another substance. So under physical properties, always remember, matter will not change its identity, means it will remain the same, only its physical state will be changed. Under chemical properties, that whole new substance will be generated. Example I'm giving, let's consider if you are solid ice, you have ice, you are melting it, so you will get liquid water, right? So water molecule is remaining the same, you are not changing that water molecule, only from solid it is going to that liquid phase. So that will be that melting, so that is its physical property. Then density, if you consider density, you have one water bottle, I have also one water bottle, both are pure. So whatever density your water bottle is having, I'll also have the same thing, right? Because water, its composition is fixed. So density will be physical property. Then color, conductivity, all these are physical property. Mass, volume. Now chemical properties means flammability. For example, if we have carbon, let's consider methane. Methane we have, in presence of oxygen, it will react and it will be converted to CO2 and H2. So that's mean from methane we are getting CO2 and H2, which are totally new compound. So that's mean in under chemical properties, always that matter is changing to other substance. So flammability, reactivity with acids or bases, then reactivity with water, then oxidation, this rusting, all of these are chemical properties. Now here another two terms we have, intensive properties and extensive properties. These are very, very important. In thermodynamics chapter, we are going to study in detail. But basic idea is intensive means independent of quantity, independent of amount or quantity, means properties which do not depend on the quantity. Example, density. I have two water sample, okay? In one case I have, let's consider 50 liter water, in other hand I have 1 liter water. So volume is different, right? But if I consider, so volume is different, so volume will be extensive property because it depends on the quantity. 50 liter, 1 liter, volume is different, so volume is extensive property. But if I consider density, 50 liter water, let's consider it is having density 1, then 1 liter water, that is also having the same density, right? 1. So that's why density will be our intensive property. It does not depend on the amount of matter. Then melting point, again the same example, you have solid ice, I have also solid ice, both the cases, you have, let's consider 5 kg, for me let's consider 1 gram. Both the cases, that melting point of that solid ice, right, it will be the same, right? 0 degrees centigrade. So melting point will be our intensive properties, which does not depend on the quantity. Next, color, conductivity, all these are intensive property. And if you consider mass and volume, I have in right side I have, let's consider 5 kg gold, left side I have 2 gram gold. So mass is different, right? Both the cases. Element is the same, but mass is different. So that's why mass is extensive property, means which depends on the amount. So from this slide, what we have understood, that physical properties, chemical properties, these two are totally different things. Physical properties means only physical changes will be there. Solid to liquid, liquid to gas or vapor, then opposite thing, right? Under chemical properties, totally new substance you will get. Next, another important thing, intensive and extensive property. Intensive means it depends on, it does not depend, independent. Intensive, independent. Intensive, independent of quantity. And opposite is extensive, means which depends on the quantity. So these are the thing. Next, here we have few, few things we have. So we have to know their symbol for their quantity then SI unit and symbol of SI unit. Just check length. Normally we use L, right? And unit is meter and symbol M. These are very important because normally NEET student they are afraid of calculations, and in calculation we need this type of basic idea. Mass, symbol M, so kg is the SI unit and kg. Time, second, small s. Current I, ampere, capital A. Thermodynamic temperature or absolute temperature. Absolute temperature, which is capital T, so Kelvin, capital K. Next, amount of substance, N, small n, that is the mole. We will study mole, I hope in the next class. So mole, MOLE, this is the unit name, and if you consider only MOL, this is the unit. Next we have IV, this is luminous intensity, candela, and CD. Don't think that this is cadmium, don't think this is cadmium, this is unit, CD. This is the idea about this, different types of quantity. Now this chart, it is important, not all the things, few things, very, very important. Example, femto. If any numerical problem, femto word is given, so that's why you have, in that case you have to remember the femto means 10 to the power minus 15. Okay, femto means 10 to the power minus 15. Next, pico. Pico means 10 to the power minus 12. This factor you must remember, and this is with respect to, let's consider 1 FM, 1 femtometer, it means 10 to the power minus 15 meter. 1 picometer, PM, 1 picometer. So this is only initials are given. Picometer, so 10 to the power minus 12 meter. Then another important thing is missing, angstrom. 1 angstrom, it means 10 to the power minus 10 meter. This is very, very important. Next, nano, 1 nanometer, small n, small m, which means 10 to the power minus 9 meter. Next, milli, 1 milliliter, or milliliter, if I consider this one, this regarding this ml, we have a dedicated slide based on that. So milli means 10 to the minus 3, then deci means 10 to the minus 1. Especially this will be used in molarity chapter, millimolar, decimolar. Let's consider millimolar. Small m, capital M means 10 to the power minus 3 molar. Then 1 decimolar, it means 10 to the power minus 1 or 0.1 molar. Okay, so these few things, and kilo already 10 to the power 3. These are the important thing. Only this thing, at least this thing you have to remember. Femtometer, then picometer, angstrom, nanometer, milli, that millimolar, decimolar, like that we will use. Okay. So next part, this one, units. Lot of units we have. If you consider SI unit, mass is represented by, that quantity is represented by kg. Kg is the SI unit. Now just check, 1 kg means 10 to the power 3 gram. A pound is not important, only this part is important. Kg means 10 to the power 3 or 1000 gram. And this is 1 milligram. So many times we have to use this thing. 1 milligram means 10 to the power minus 3 gram. And micro means 10 to the power minus 6 gram. Next, length. Already I said 1 angstrom means 10 to the power minus 10 meter. So you can easily convert that into centimeter, because see, 10 to the power minus 10 meter. Now instead of meter, if you write, already we know 1 meter means 10 to the power square means 100 centimeter, right? So 10 to the minus 8 and 10 to the power 2, if you calculate 10 to the minus 8 centimeter. So already I hope you know this thing. Next, picometer. So these conversion really important. Picometer means 10 to the minus 10. Nanometer means 10 to the minus 7 centimeter or minus 9 meter or 10 angstrom. So 1 nanometer means 10 angstrom. 1 nanometer means 10 angstrom. And in terms of picometer, 10 to the 3 picometer. And if you consider this volume related thing, this is very, very important. Put star mark, this one, very, very important. In most of the numerical problems, especially in physical chemistry, we have to use this relation. And sometimes you might be confused. In question, decimeter is given, decimeter cube. Now, how to use this decimeter cube? Sometimes you need something in liter. Actually, 1 decimeter cube means 1 liter, right? 1 decimeter cube means 1 liter. So here it is clear, right, from this relation. So this type of conversion we need. Already say 1 liter means 1000 centimeter cube means 1000 ml. So that's mean 1 centimeter cube or 1 cc means 1 ml, right? 1000 ml means 1 decimeter cube or 10 to the minus 3 meter cube. So these are direct, conversion. Only it will be useful in numerical problems. Achha, next, density. Density is kilogram per meter cube. If you put kilogram means 10 to the power 3 gram and meter cube means 1 meter means 10 to the power square. So you can calculate this one. So 10 to the power 3 gram divided by 10 to the power square centimeter cube, right? So that's mean 10 to the power cube into 10 to the power minus 6 gram per centimeter cube. So that's mean you will get 10 to the power minus 3 gram per centimeter cube. So density unit. So up to 4 here we have. Next, this one. This pressure, this one, very, very important. This pressure part. What are the units of pressure? 1 atmosphere is equal to 760 torr. And 760 torr means this torr can be replaced by mmHg, means millimeter of mercury. That height, mercury height, or 76 centimeter of mercury. Okay, so 1 centimeter means 10 millimeter. So that relation we are using. Next, 1.01325 into 10 to the power 5 Pascal. So Pascal is another unit. Say total how many types of units here we have on the basis of pressure. One is ATM, torr, mmHg, Pascal, Newton per meter square, bar, dyne per centimeter square. So all these units are very important. 1.01325 into 10 to the power 5 Pascal, or you can replace Pascal with Newton per meter square. Or 1 ATM is equal to 1.01325 bar. So that's mean 1 bar will be equal to 10 to the 5 Newton per meter square. So this is also important. 1 bar will be equal to 10 to the 5 Newton per meter square. Okay, and another conversion we have here in dyne per centimeter square. Next, work and energy. 1 joule is equal to 10 to the 7 arg. 1 joule is equal to 10 to the 7 arg, and this is the most important thing. 1 calorie is equal to 4.184 joule. Lot of times we have to calculate this thing. 1 calorie will be equal to 4.184 joule. And this one is very important. 1 electron volt is equal to 1.602 into 10 to the power minus 19 joule. So this conversion is also very important. How to convert electron volt into joule? Just you have to multiply this 1.602 into 10 to the power minus 19. Just remember this factor, it is coming from the charge of electron. 1.602 into 10 to the minus 19 coulomb. Remember that thing. From charge you are getting this. So another thing we have force. 1 Newton. Newton is the force unit of force. 10 to the 5 dyne. Power is watt. 10 to the 7 arc per second. Watt. This is important. 1 watt is equal to 1 joule per second. And temperature. This is also very, very important because multiple times we have to use this equation, especially first one. How to convert temperature from Kelvin to degree centigrade or degree centigrade to Kelvin. Just we have to use this formula. If I say 25 degree centigrade, so how we will convert that into Kelvin? So just 25 plus 273.15, it will become Kelvin, right? So you have to add. If I say 300 Kelvin, so how we will convert that into degree centigrade? So 300 minus 273.15 Kelvin. This will be degree centigrade, right? So using this 273.15, we have to convert degree centigrade into Kelvin. And always remember, whenever we have small t, normally we represent small t, to present time. But if I write T degree centigrade, so this is temperature in degree centigrade scale. And if we write capital T, it represents, so capital T, it is also time. It represents time, but in this case, T Kelvin means absolute temperature. So there are some similarities, or don't be confused with that. Whenever temperature context is there, small t means in degree centigrade temperature, capital T means in Kelvin scale temperature. Correct? So these are all about the units. I have few questions. Just few minutes ago I said blood is homogeneous or heterogeneous? Blood is heterogeneous. So that already our slide is over. So okay, let's consider blood. Blood is homogeneous or heterogeneous? You might be confused that if I consider blood, it is a transparent, homogeneous, we can consider it is a homogeneous solution. So it must be homogeneous because it looks like the same everywhere, right? But actually this blood is heterogeneous. Why? The reason is, if you just look this blood with the help of microscope, then you will see a lot of particles like hemoglobin, like RBC, WBC, all those things, proteins, a lot of things you will find, right? So those are actually colloids. This blood, it is not actually a solution, it is a colloidal solution, not a proper solution. Colloidal solution means if you have a sample of blood, lot of small particles will be there. Okay, those are not fully dissolved, those are suspended. This is called colloid. Actually this is called colloid. Any colloidal solution is called heterogeneous solution. So one example is blood. Another example we can have, that is milk. If you consider milk, so there also the same story. It looks like pure white, only one type of thing is there, but it is not actually the same thing. If you look through a microscope, lot of protein molecules you will find. So this is also colloidal system. Any colloidal system means heterogeneous system. Third example, chalk powder solution. If you consider chalk powder solution, same example, same story, lot of particles you will get, and that will be the heterogeneous system. So this is the thing. Next, let me check what important points are there still. Acha. Next one important part is there, combustion. Here, flammability, ability to burn in oxygen. I explained this one. Now one relevant question is, what does it mean? What do you mean by this? There is a term called combustion. So any combustion means it must react with oxygen and it will produce either CO2 or H2O or both with enormous generation of heat. I'll give one example. Let's consider CH4. CH4 we have. If it reacts with water, then it will produce CO2 plus H2O. These two are totally new compound, plus lot of heat will be generated. Now if you balance this equation, so put CO2 and H2O, so put 2 there, and 2 to 4 oxygen, so put 2 here. So this is balanced equation. Now in this case you can see this CO2 molecule, it is converting into CO2 and water with liberation of heat. So this will be called as combustion reaction. If you consider only carbon, C plus O2, from that you can get CO2. Here also a lot of heat will be generated. So this is also combustion reaction. Why? Because here also you are getting new compound which is CO2 and heat. Okay, so point is either CO2 or H2 or both will be produced. If you consider H2 plus O2, from that you will get H2O, correct? H2O. So if you balance, what you will get? If you balance this thing, H2O, put 2 here and 2 here, so you will get water, and here also a lot of heat will be generated. So here what I'm trying to explain, whenever this combustion word, burning word, this thing you will study, especially this combustion word, always think in the right side either CO2 or H2O or both will be produced and lot of heat will be generated, means exothermic reaction. So any reaction which is producing heat, that will be called exothermic reaction. And in the left side oxygen must be there. Okay, so hydrocarbon is reacting with oxygen and forming CO2 and H2O with liberation of heat. This is called combustion reaction, and what you are observing here. Next, here reactivity with water. What does it mean? Reactivity means what? If you put some, let's consider sodium. This is coming from alkali metals. All alkali metals, alkaline earth metals, these are all highly reactive. Why? Because they are having electrons which is in the outermost shell, so that will try to go towards other species. So this sodium, it will react with water and it will form sodium hydroxide, okay, with liberation of lot of heat. So reactivity means that sodium with water, it will produce sodium hydroxide, lot of heat will be generated, and because of that heat, that burning, that fire you will observe. And here rusting, it is actually redox reaction. You will study that redox reaction. In redox reaction, basically oxidation and reduction both will be happening. Okay, so that is redox reaction. And reactivity with acids means if you put some, for example, zinc or zinc in water, so H2 gas will be liberated, H2 gas will be evolved. So that is the reactivity with acid. So this type of terminologies will be there under chemical properties. See, today whatever I discussed, these are all basic things. Okay, these are all basic things. There is nothing new, I think. But your task, since this is our first class, so your task is, you have periodic table, total 18 groups we have, right? Total 118 elements and 18 groups. So your task will be to remember that periodic table as per group. I'm explaining. So let's discuss here. Let's discuss that part here, because that is very, very important. In chemistry, if you want to score very well, you must remember this thing. So total 18 groups we have, 1, 2, then 3, 3, 4, 5, 3 to 12 we have. Next 13 to 18, okay, and bottom we have A block. So this first two are called S block. Next, this part is called D block, and last that 5 that is called A block. And this is P block. This is P block, and last one is called A block. So S, D, P, and F. This is the structure of our periodic table. So you have to remember elements name as per their group. You will get lot of advantages in future. Why I am saying, for example, just now I discussed that sodium is reacting with water, right? So if you know that sodium belongs to this group 1, now whatever, if you study this, if you study the properties of sodium, then you can guess that what will be the properties of other elements present in that group, like lithium, sodium, then potassium, rubidium, cesium, francium. So other elements which are present in the same group, they will also show the same type of property. So if you put sodium in water, it will react violently. Similarly, if you put potassium in water, it will react violently. The same tendency will be there. So that's why, especially this type of reactivity things or electronic configuration, so here all metals, they're having one electron in the outermost shell. That's why first group we are calling. Next, if you consider beryllium, magnesium, calcium, strontium, barium, radium, so here outermost shell is having 2 electrons. That's why group 2. Okay, that's why group 2. So if you remember as per group, if you know the properties of one element, you can guess the property of other elements. That is the advantage, and outermost electron configuration will be the same, right? So at least up to 6th period, total 7 periods we have, right? 1, 2, 3, 4, 5, 6, 7, total 7 periods we have. So your task will be to remember at least up to 6th period, obviously along with F block, lanthanides and actinides, along with this F block. So if you remember this thing in atomic structure, okay, in atomic structure, electronic configuration, then periodic classification, that chapter, P block, we have S block, P block, D block, F block, different chapters we have. Lot of advantages you will get just by remembering this table up to 6th period group wise. So that is your task. Next, what we have already, I think we have discussed a lot of things. This is also done, this is done, units. Okay, for today I think this is enough. So this is our Telegram channel. You can join this channel. This is QR code, just scan this. Next, this is our YouTube channel. Already, if you are watching this, already you know this thing. Just if you find something, good content or something, just you can follow this. Okay, thank you very much. This is our first class. Tomorrow also we are having class, 11th class. So next part will be there, and step by step. Now we are little slow, and class timing also little less. So tomorrow we will discuss something more important thing, and every day we'll be discussing content with respect to exam. Why I am saying there is no ending of knowledge, so that will be added with time, but we must focus on exam, and with respect to that exam, whatever topics we need to learn, first we have to finish that. If we have extra time, yes, we will invest to improve our knowledge. So that is our conclusion. So today, this is the end of this class. Thank you.